right, hello ladies and gentlemen. We are doing the Unit 5 Study Guide review. This review is focused on exponents and all the different exponent rules, geared more for Algebra 1 and not so much Algebra 2. It can be a helpful review for Algebra 2 because a lot of the rules will overlap, but in Algebra 2 you take those rules to, let's call them, a whole new level, especially with radicals. So this review is more basic exponent rules and therefore should focus mainly for Algebra 1. Now, if you take a look at the answer key for this top section of the review packet kind of defines the 6 rules that we have: when to add, when to multiply, when to subtract, when to flip, and when anything becomes 1 or itself. So if you take a look at this, these are kind of generic references that we tend to refer to exponent rules, saying that, add powers when they're same bases, or multiply when it's exponent to exponent, all these kind of definitions here. But the main focus, I would say, would be over on the side here, this idea of some generic examples. So you have like a to the 5th times a to the 2nd. That means you have 2 separate a's, and therefore you're going to bring them together through addition. When you have just one a but 2 exponents, you need to go ahead and multiply the exponents. If you have, for example, this next piece, that's a little hard to read. It is a 2 down below. So if I go ahead and change that to a 2, it's a little hard to see. Okay, so that is 2 down below. So you have a to the 5th over a squared. Anytime you have division happening, you should be doing subtraction and getting that a to the 3rd. Anytime you have a negative number, remember to move it to the, tends to be to the bottom, but I hesitate here. Notice how I use the word flip, because sometimes you'll find that negative in the denominator. So for example, you might find it looking something like, this is rule number 4. Let's say you have 1 over a to the negative 5th. Well, now that negative is on the bottom, and you should actually be bringing it up to the top, and you're going to have a to the positive 5th over top of 1. I would also like to point out some other details, and we'll come across these in a little bit later. With addition, sometimes you're going to see problems that look a little more like this: a to the 5th times a to the negative 2. And frequently people see this negative 2 and they go one of 2 directions. They're either going to say, hey, this should actually become, a squared on the bottom, and then this a to the 5th is going to be on the top. In which case, 5 over 2, you subtract that and get a to the 3rd. You can also follow this rule of addition and actually say, what is 5 plus a negative 2? Well, 5 plus a negative 2 gives me a to the 3rd, and you get the same answer. Now, on the same exact note, sometimes you're going to see things like this. Let's say you have a squared times a to the negative 5th. And you're like, okay, well, let's use this rule. Let's add. Let me zoom in just a little bit. So you're thinking to yourself, okay, let's go ahead and add these problems. I would say that when you take 2 plus a negative 5, 2 plus negative 5 should give you a to the negative 3rd. And frequently kind of people stop there because they're like, that's the best you're going to do. But anytime you have a negative, you should never leave it in the exponent. That actually goes down to our negative rule and should be moved down below. Okay. So again, those are just kind of the 6 major rules. You get into new rules, especially when you get into radicals. But for Algebra 1, these are the 6 rules you should really focus on. Feel free to stop the video and examine these a little bit closer. Otherwise, we're going to go ahead and move on. Okay, onward to the next section. This section down here asks you to expand. Don't overthink this. Frequently people see, 6 to the 7th power, and I don't have a nice big calculator with me, but I have my phone calculator. So if I go ahead and set that up, they think, oh, well, if I do 6 to the power of 7, and they hit equal, and they're like, oh, that's my answer. That should be the answer that I get. My issue here is that's not what expanding means. Expanding means to simply write it out longer. If they wanted to know the value, they would say, evaluate or solve or, something along that lines. But expand really just says, If you have 6 to the 7th power, that means you have 1, 2, 3, 4, 5, 6. And then if you want to throw little dots in between, that'd be a smart idea. So you have, sorry, not 6, I missed one. It's to the 7th power. So the 7 tells you how many you should have. 1, 2, 3, 4, 5, 6, 7. And the 6 tells you what number you're actually repeating. So for the next one, you have x to the 3rd. That means you should simply have 3 x's. And then again, if you want to put dots in between those. Now this last one's actually kind of fun. There's 2 ways you can see it and say, okay, I need 3 of these. So if I have a 3x, 3x, and 3x, I now have 3 of those. I had someone today come up and ask me, well, could I also look at it as 3 to the 3rd, x to the 3rd, and then write it out as 3 times 3 times 3, along with an x times x times x, and you absolutely can do it. Either way is fine. If you actually take a look at the first answer, there are 3 x's and there are 3 3's. So they end up being the same, and order doesn't matter. It's like, you know, someone asking you what's 4 times 1 and someone else asking you what's 1 times 4. Either way, you're still going to get the same answer. So kind of keep that in mind. You can do it either way. These are both technically expanded. Now onward to the big heart of this unit, which is just simply practicing problems. So if I go ahead and take a look at the first one, I refer you back to, if you actually copy down the chart up above here, you'll actually notice, and let's see if I can get them on the same screen there. You'll notice that with this example here, it's a to the 5th power squared. Looks very similar to our first example, which is x to the 6th power to the 9th power. So slightly different numbers, and instead of an a, it's an x. But the rule is still going to apply that I need to take 6 and times it by 9, which should give me x to the 54th power. Remember to keep that x. You know, we're only talking about the exponents. We're not trying to change the base or anything crazy like that. If you're ever in doubt and you're like, I don't really know if it's supposed to be multiplication or anything, do remember that 4, very similar to what we talked about up here, is really just saying that you can write it 4 times. So if you want to have a to the 7th times a to the 7th times a to the 7th times a to the 7th, you can absolutely do that. You could, even if you really got excited and absolutely love this, you could take this even further and say I have 7 a's, 3, 4, 5, 6, 7. I have another 7, 1, 2, 3, 4, 5, 6, 7, and another 7, and another 7. And then you kind of just count how many you have, and that's going to be your total number. Now, the whole reason that we learn all these exponent rules is so that we don't have to write this out so many times, and I can simply say what 7 plus 7 plus 7 plus 7 gives me a to the 28th. So really, you would have had to write out 28 a's, and that just doesn't sound fun. Or if I look at the first one, I would have had to write out 54 x's. That would have taken me forever. So really knowing these exponent rules of when to add and when to multiply, really helpful. And I will say that in this particular example, when I got 28, is because I added the 7's and got 28. If I take 7 and I multiply it by 4, 7 times 4 would also give me 28. So it doesn't really matter whether you multiply or, you know, write it out and add them. Just kind of keep in mind that if you don't write it out in, you know, 4 separate a's, then, and you just leave it in this form, you do need to do multiplication, 7 times 4. But if you want to take that 4 and say that I have 4 of them, now you have separate a's. You have an a here, and an a here, and an a here, and an a here. That means you're going to go ahead and multiply them. Okay, so again, kind of referring to the rules up above, that if you have one single a but 2 exponents, you need to multiply. But if you have multiple a's, you can go ahead and add them together. Now in this next problem, along with problem 4, it's really cool because you have a couple different rules here. First off, you could look at this and say I have an x and an x. So in theory, following the rules up above, that's going to mean that I need to go 8 plus a negative 5. Okay, so 8 plus negative 5 gives you negative 3. No issues there. That's my final answer. Now some people are like, oh, but here's a negative. I need to get rid of that negative. That's absolutely true. So you could also move that x down below. So I took that negative 5 and moved it to the bottom and made it positive. And now what I have is a division problem. So if you go up above and say what happens when we do division, you should be doing subtraction. So 8 minus 5 gives me x to the third, again, getting that same answer. Now I refer back to the point when I made that 4 is very, very similar. Because with 4, I could do it either way. I could move the x to the bottom, or I could do subtraction. I'd like to show you both ways, because watch what happens here. If I do 6 plus 10, or sorry, 6 plus a negative 10, that will give me x to the negative 4. Okay, but if I go ahead and take this and move it down below, that's going to give me x to the 6th over x to the 10th, in which case, according to division, I need to subtract. So that's 6 minus 10, again gives me x to the negative 4. Now you should notice that it got us to the same answer, x to the negative 4, x to the negative 4, which means we absolutely did it right. But I would like you to take notice of, or a reminder of, what is division actually saying? Division is actually saying that I have 6 x's on the top and 10 x's on the bottom. Bear with me. 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, according to the rules of having like 4 over 4, we can go ahead and match up our pairs and kind of cancel them out. Now that leaves me with 4 x's in the bottom. So this is just a reminder that when you see that negative sign, you should actually be flipping it. So because I had that negative 4, I needed to move it to the bottom, which makes absolute sense because when I started doing these canceling out, the 4 that I had left over ended up being on the bottom. So the 4 that you have up here should also be on the bottom. So kind of keep that in mind. Number 5, again, there's usually 2 ways to do everything. You can choose to do subtraction, 7 minus a negative 6. Careful with the minus. That's going to end up becoming 7 plus 6. Okay. Or you can simply say, let's take this 6 and move it, in which case you're going to have x to the 7th and an x to the 6th all over top of 1. And now it becomes very similar to the problem up here. You have an x7, x6, just add them together, which is what we got right here. And then the very last one over here, not a very hard problem, shouldn't take very long, but take notice of where that negative is actually. So that negative is only on the 10, in which case when I set up my fraction, only the 10 has to move. And a reminder, something that I see quite frequently, is that the 10 travels with the h. So sometimes I see people like having like 3h over 10, but the 10 is not actually a number. It is simply an exponent. And reminder, exponents is really just saying an easy way to write out, 10 h's, right? So there isn't actually a 10 in the problem at all. There's no 10. 3, sure, I could hand you $3, but this 10 is not saying like, oh, $10 that I can hand you. What it's actually saying is I have 10 h's. There is absolutely no 10. It's just that I have a lot of h's, and instead of writing out a lot of h's, I'm just going to say that I have h to the 10th. So when you bring it down, you need to bring it down with the h. Okay. Going on to the other side, there's lots of practice problems in this worksheet. Many of them overlap. So again, here's that negative. These two look very similar to me. Number 8 is probably a little trickier. I'd like to point out that this is negative. So if I think about it over top of a 1, that means I have to move it down. And I'm going to get 2x to the 5th. That would not be your final answer. That was a good move. Good thing you got rid of the negative. But now don't forget that that kind of has to get, in theory, distributed. And therefore, you're going to get something that looks like 1 over 2 to the 5th, x to the 5th. Okay, and honestly, the 2 to the 5th, I would encourage you, especially on the test, maybe in a quiz, your teacher would be fine with you leaving it as 2 to the 5th, but especially on a test, you need to actually type into the calculator 2 to the 5th. I wish that I had a calculator like you guys will be using in class, but frequently you get stuck doing calculator work on your phone anyways. So I will tell you that this button on the calculator, or the phone calculator, it says x to the y power. That's saying, what is x? So first of all, I had a 2 to the 5th. So my x is 2. Then I click this button, which asks you, okay, now what power do you want to raise it to? I want to raise it to the 5th power, and then you hit enter, and you get 32. Okay, so if you wanted to see what your final answer would look like, you would have a 1 over 32x to the 5th. Okay, so remember to kind of take that out. Number 9 is very similar to the one that we did on the front, letter F, which I now take notice. I think the problems on the previous page, oh no, is number number 6. I don't know why I called it F, but number 6 on the front page. So that one's very similar to number 6. Looking down at a couple of other problems, a lot of these rules, again, it's just a matter of getting lots and lots of practice as to what rules to do and when. Number 10, a common mistake that people quite frequently do. Let me bring it in a little bit. But something I see quite frequently with problems like number 10 is going to be that when people see this 3, they are like, okay, yeah, I know that, maybe you know that m is to the first power. You know that if you have an exponent to an exponent, you multiply, and maybe you even figure out that it needs to go to the m. So I'll see people get this, and they'll say m to the 3rd and then n to the 18th, and that's fine because, the m was a 1, so 1 times 3 gave you 3, 6 times 3 gave you the 18. And then frequently I see people just put a 2 out in front. The thing is, 2 is very similar to the m. Technically, the exponent originally was a 1, so that 3 has to go to the 2 as well. Now, some caution that I offer here. Another thing that I quite frequently see people doing is they're like, okay, I know that the 3 is supposed to go to the 2, so 3 times 2 gives me 6, right? Makes sense. However, I would like to remind you that 2 is a big number, right? And it's a very big number. 3, on the other hand, is very teeny weeny. Okay? So trying to say that I want to take 2 and multiply it by 3 is like saying that, I don't know, a human wants to marry a log, right? It doesn't work, okay? One is human, can live, can breathe, can think, can make mistakes. A log, on the other hand, just kind of sits there, right? So the 2 and the 3, totally different. And if you actually think about what does the 3 mean, it means that I have three 2's, right? Well, what's 2 times 2 times 2? 2 times 2 is 4, times 2 gives me 8. So 6 doesn't make sense, because if I have 3 2's, that gives me 8. It does not give me 6. So kind of keep that in mind. If you choose to simplify this any further, the 2 to the 3rd would become 8, the m would stay m, and the n would stay n. So kind of just keep that in mind. Be very careful. It's very tempting, especially when occasionally we will actually multiply numbers. So for instance, this one you have a 6 and a 2 to the 3rd. Those are going to end up getting multiplied because the 6 is big and the 2 is big. So if I have a big 6 and a big 2, it kind of makes sense that I can multiply them. It's not like one's big and one's small. Now, the issue here is that 2 is not alone. There's a 3 attached to the 2, which means I can't simply do 6 times 2. If it was just a regular, good old 2, minding its own business, that's fine. But I don't have a regular old 2. I have a 2 with a little 3. Well, from talking about over here, we know that 2 to the 3rd is actually 8. So now what I have is a big 6 and a big 8, and you can go ahead and take 6 times 8 and get 48. Now, as far as the x's go, they're separate x's, you add them. And as far as the y's go, you add those as well. Do remind that this y technically has a 1, so 7 and a 1 is how I went ahead and got 8. Now, some are jumping around a little bit. Some problems that I want to draw your attention to. A reminder, for instance, this problem here, you have an r to the 0, technically becomes a 1. And frequently we just say kind of scribble it out. It's not really going to make much of a difference whether it's a 1 or out of the 0. It doesn't really make a difference. So you're still going to have a p to the 8th, m to the negative 5th, p squared, and m squared. This negative 5 then needs to move down. That means it's going to join the 2, and become m7. And then, of course, you have your p's which will become P6 on the top, again if you cancel out, and then M7 as your final answer there. Very similar things are going to happen with 14. You got a lot of negatives, so keep in mind here's a negative, that means move them to the top. Here's a negative, that means move them to the top. And here's a negative, which means move them to the bottom. So a lot of kind of shuffling around there. 15 is going to be the same idea. They're both negatives, so they end up switching. Number 13 is very similar to 11. Okay, you have an 8 and a 7. Those are just regular 8 and 7s. Neither of them have any exponents. So just think to yourself, what's negative 8 times negative 7? Should give you a positive, sorry, I don't know, I said positive. Positive 56. And then you'd go ahead and say, here's an F, here's an F. Here's a G, here's a G. And then the last piece, don't forget about the H. He has feelings too. Moving on to kind of the last couple of problems here. A reminder, this piece up here is to the 0. Now, frequently, some people see the 0 and they think that means the exponent becomes 1, but it's really saying that the entire thing, anything to the 0 power, simply becomes a 1. So what this looks like now is a 1 over 5x to the negative third, or sorry, y to the negative third. This y then needs to move up, so it becomes positive, and the 5x is still on the bottom. So just a reminder, like with the 0 rule, again, here's a 0, the whole thing becomes 1. All right, now here's another 0. That 0 is only attached to the 5, so only that piece will become a 1. And that means I'm left with a 1 on the top and an AB squared on the bottom, final answer. And then the last one, again, I would highly recommend just kind of crossing out anything with the 0 power. Then ask yourself, this piece needs to move down, this piece needs to move up. Combine like terms, final review. This is going to become p to the 15th over p to the 5th, and then the z to the 8th. Once you get it to this point, you do have a p and a p, one on the top, one on the bottom. So remember that that's going to end up being subtraction. So 15 minus 5 gives you p to the 10th. Again, frequently I look at this, some people struggle with fractions. I look at this as saying I have 15 on the top and 5 on the bottom. Maybe you could say, oh, maybe, you know, Joey has $15. Joey has $15 and I don't know, Chloe has $5. Well, you know, if you try to figure out what the difference is, Joey has more. Therefore, that $10, that remainder, should be on the top on Joey's side. And then you still have that z to the 8th, and that's your final answer. If you want to throw it over top of 1, you can, but it's really not going to make too much of a difference. Okay, so you know, I skipped around a couple problems. Some of them I didn't kind of complete all the way, but you know, I did examples very similar to them. So feel free to give some of these a try all by yourself. Final note, I promise. Notice I'm looking at these two, and to me these look really, really similar. Right? 1 to 2x to the 5th, 1 to 5x to the negative 12. Please remember that that negative 12 is only to the x. It's not to the 5. So when you think about moving it, leave the 5 alone. He's perfectly fine. And then send the 12 down below. Okay? Versus over here, since it's grouped, you know, that 2x is kind of grouped together. That means that the negative 5 is going to the entire group. And that's why we moved the entire group. So just, you know, be careful with parentheses. They do make a big difference. And good luck with your studies.